Hi everyone, welcome to my channel. In this very first video, I'm going to cover one of the most important and challenging role of the software industry. Yes, architect. I'll be covering a detailed roadmap and tips for becoming a software architect. There are many roles in our industry with related to software architect. Like we have software architect, enterprise architect, data architect, solution architect, cloud architect, big data architect, and other architects. So I'll be covering the common foundation layer which is required to become a software architect. A lot of people try to reach me out for sharing insights on becoming an architect. Some came up with very few years of experience, 2 years, 3 years, 4 years, and they were striving for becoming an architect. First of all, we must understand it's a long journey. It takes time. It takes a lot of efforts. It's a combination of multiple skills. One has to gain a technical proficiency. One has to acquire soft skills. One has to learn so many things. One has to try so many things. One has to gain the practical experience. Then you can become a skilled architect. Before moving into the technical part, like what are the different areas, what are the different skills required, I want to share few tips. Whatever the roles you are, whatever the experience you have, what you can do is, whatever the field you are, first of all, try to gain the proficiency in that field and try to explore the new areas. Try to see whatever the system you are working, how that system is working. Try to gain new technologies. A lot of people reach me out and say that, I learned the technology. Since I'm not working on these technologies, so how I can imbibe that knowledge? If you have learned something new, just share that knowledge with your peers. Just share that knowledge within your group. Just share that knowledge outside the group. So once you will start sharing that knowledge, people will ask you technical questions. In that case, at least you'll get a confidence whether you have gained that knowledge or not. Even if you have gained the knowledge, then if you will teach someone that the concept or the knowledge that you have gained, that will imbibe in you, and then you'll be able to use that one. Try to read as many books as you can. Whatever the experience you have, if you are into programming, read programming books, read data structure books. If you are into microservices, read about microservices. If you are into data, read about distributed computing. If you are in the early stage, if you are in middle stage, if you are into the higher stage also, you can read books as per your experience. But try to read as many books as well. And apart from reading, try to explore the new areas, like very common areas, though I'll be covering about cloud computing concept, about the containers. Start thinking about how to build a system layer by layer. Think about a system. If given a chance, can you build a system? What it would take to build a system? Do you know all the components? Even if you know all the components, then can you fix them all? Are you aware of all the components, or do you not? In terms of databases, in terms of storage option, in terms of cloud option, in terms of gateways, in terms of load balancer, in terms of searching capability, in terms of authentication, a lot of areas are there. So block by block, try to gain that knowledge. Build a strong foundation, at least from computing point of view, storage point of view, or networking point of view, from the cloud point as well. And start reading engineering blogs. There are some good engineering blogs are there in terms of Netflix is there, Adobe is there, Uber is there, and some good companies. They publish their blogs and they share their best practices, their best architecture. So by reading them, you'll get the motivation and start implementing small solution, and then try to build the new one. Try to explore the system that you are already in. Try to explore the new areas you want to. So the ultimate aim is you should try to explore the areas. You should try to expand your horizon. More and more areas you will gain, more and more concept you will read, more and more systems you will read. So that will build your foundation. Try to think about, can you build the architecture? Do you know all the flows? Do you know how it will work? Do you know about the different non-functional requirements in terms of scalability, in terms of load, in terms of consistency, in terms of durability? Are you well versed with basic fundamentals of ACID, cap theorems, or other concepts which are very much applicable? So before actual moving into those things, just try to get the important part, whatever is very much popular in the industry, be it terms of some of the most important DevOps tools, some of the MLOps concepts, some of the basic knowledge of data science, some of the data engineering concept, some of the cloud computing concept, or some of the front end concept, or some of the mobile concept, whatever the domain you are. If you want a proficiency, you need to understand that area, you need to understand that landscape. So following all these steps will help you in your journey, and then you will get a good confidence. Now let's move on to the detailed roadmap, where I will share that step by step what are the different technologies and tools that somebody should try to get over a period of time to get a good confidence in this journey. The very first skill that one must have should be the programming skills. Yes, it may happen that maybe it may vary from organization to organization, that being an architect you might not be able to code on a daily basis. But what are the roles and responsibility of the architect and why they need to learn or get a proficiency in at least one language? So being an architect, you lead a team of developers, you collaborate with them, and then you review their code. You do a lot of POCs, POTs on latest technologies to check the viability, to check the feasibility of the particular technical solution. So if somebody is proficient in programming language, he'll be able to quickly do the POC, would be able to find the gaps, would be able to find the bottlenecks, and then he'll be communicate to the different stakeholders. Similarly, let's say you are working in a project which is a very complex project, and then a junior engineers, they want your guidance on some production issues, or they want to improve the efficiency, or they want to remove the bottleneck. For that one, if you are very efficient in code, so then you'll be able to go at the code level and then you'll be able to help them out. So all in all, even being an architect, the very first thing is one should have a proficiency in at least one language. It will be great if you have proficiency in one language and a working knowledge of one or two languages. Moving on to further, once you have built this strong foundation layer, the second part is architectural pattern. So architectural pattern are very important aspect of software development. So they give us the standard structure to how to build a system design by facilitating availability, scalability, maintainability, and other non-functional requirement as well. Architectural pattern also helps in setting up the blueprint of the system design, that how we have to divide the different layers, how we have to divide the different subsystem or modules, how they will interact, what are the roles and responsibility of each and every system. So that's why these patterns are very important. So some of the prominent are microservices pattern, master slave, event driven architecture, MVC, a lot of other architecture patterns are also there. So being an architect, or if you are striving to become an architect, you should try to explore different architecture patterns. It may happen that whatever the domain that you're working, let's say you're working in a microservice world, then you should be proficient in at least a complete ecosystem of microservices. What are load balancer, what are application gateways, how we have to place the security in place, APIs, a lot of other things. If you're working in event-driven architecture, then you must know what are the different components involved to make it work. One should have a fair knowledge of all the architectural patterns, at least have a working experience of 5 to 6 different architectural patterns. He should be able to make a trade-off between like why to choose which one and in which use case. By building the foundation of different architectural pattern, you'll be able to design a system in a very better and effective way. And moreover, you'll be able to compare the different trade-offs between different technologies and different architecture. So architectural patterns are very important for becoming a software architect. So there are a lot of things. One should have at least operational knowledge of a couple of things. So few important things are container, orchestration, cloud computing, different cloud providers, CI/CD, serverless. It may happen that some of these areas you might not have explored so far, like containers or orchestration. But if you see, after virtualization of microservices, container and orchestrations are very much important. Even if you don't have any exposure, at least you should try to get your hands dirty, because these things are very important. These are applicable everywhere. All the big companies and all the area, if you see in everywhere, these things are being applied. So if you're striving for an architect, at least you should have a working knowledge of containers, orchestration, and then of course the cloud computing. The companies, they have set up their infra on the cloud as well. So one should have a fair knowledge of at least a basic computing concept in terms of compute, storage, network, and then different storage options, different databases, different NoSQL databases in terms of setting up the load balancer, exploring machine learning, whatever the cloud that you're working. At least if you are in AWS, try to explore more services. If you are into Azure, try to explore those areas. So all services are very similar. If you have gained the proficiency in one of the cloud, then once you will try to move to the another cloud, it will become very easy because you'll be able to map all those services and all those concepts on a new cloud as well. But if you're striving, then cloud knowledge is must. So container, cloud knowledge, and then basic things that we do as a part of our code, like CI/CD, bit knowledge about the different distributed systems, how they work. And if you are into microservices world, then altogether, as I mentioned, different load balancer, CDN, gateways, service registration, all those components which are part of the microservices. And then serverless is also very important. So if you can also try to get some hands-on experience in serverless, it will definitely help you. Overall, from working experience, operational knowledge point of view, you should be comfortable with container orchestration, cloud, and you should be very well versed with CI/CD. And then you can try to explore other areas like serverless or different load balancer, CDN, gateways, different cloud services that you can try to achieve with the passage of time. So the next area is databases. Databases are very important. Like whatever the work you are doing, whatever the domain that you're working, you will be dealing with databases. There are, like, at high level, we have two categories of databases. We have SQL category and we have NoSQL. In SQL, we have MySQL, we have Postgres, and we have other databases. In NoSQL, we have like broad categories like document databases like MongoDB, CouchDB, column-oriented databases like Cassandra, HBase, key value-based databases like Redis, DynamoDB, graph databases like Neo4j, TigerDB. So a lot of databases are there. It may vary from use case to use case, or it may vary from company to company, the domain that you're working, but you might be dealing with the databases. So if you are striving for this role or you are already in that role, one should try to expand his horizon in terms of different databases as well. In terms of, like, if you are coming from the RDBMS world, that you should be at least very thorough with the SQL kind of thing. You should be comfortable with the SQL. If you're coming from NoSQL kind of thing, you should have a fair knowledge of CAP theorem, which particular database has to apply where, what are the different pros and cons of choosing a different database, what are the different offerings on cloud with respect to databases. There are very popular databases available in the cloud as well. But overall, one should have a fair understanding of choosing a database and using a database, and that to a different broad categories. Let's move to the next section. There are a lot of tools that one should be very comfortable in using those tools. Basics one from code point of view, Git from code building point of view, Maven, SBT, and from code improvement point of view or improving the code quality, plugins like find bugs, code style, check style, PMD, and then few Confluent services like Jira, Wikis, Sonar, Jenkins. If you're coming from Java world, then JVisual VM or jmeter for load and performance, and for API, Postman. If you are into and some logging frameworks such as Splunk, ELK, Datadog, these are the very common tools which everybody uses. So one should try to get knowledge of these tools. If you have explored all these tools, then good to go. Otherwise, if you haven't explored some part of the tools that I've mentioned, you should try to explore that angle as well. We talked about so many tools that one should be very comfortable. And one important aspect of being an architect is you would have to create so many diagrams in terms of architecture, flows or something. So one should be very comfortable, or if somebody has not explored any tool, one should try to get a knowledge in terms of using those tools to create diagrams, to create different architecture, different flows, because these are the different things which are very much required in that role, where you would have to come up with the architecture, you would have to come up with the high level diagrams, you would have to come up with the different data flows, you would have to come up with the different things. So that way, if you're handy with these tools, which there are so many tools are there, you can choose as per your convenience or as per the existing knowledge you have, but you should try to explore that tool which will really help you in this role as well. So next part is APIs. Someone has rightly said the two A's that will gonna rule the world: artificial intelligence and API. So whatever the work that we do in terms of service to service communication or interacting with any component, APIs come into picture. APIs are very much important. One should have a fair knowledge that how to develop the API and how to deploy the APIs. So there are various protocols like REST is there, SOAP is there, and of course GraphQL is there. one should be very comfortable in at least one of the area, and then he should be able to know that which particular protocol to apply where, like where I can apply the GraphQL, which way GraphQL is efficient from REST, where I have to apply the REST or where I have to apply the SOAP. After understanding the API, you should also try to explore new angle, which is message broker, message queue, or messaging system, something like Kafka. There are other options as well, like Kafka has become the de facto standard, so you should also try to explore Kafka. And Kafka is very popular in microservices world, where you have to interact between the two services, where you have to send the messages, between the two services. Kafka is very popular in real-time streaming. Kafka is very popular in IoT world. So at least a basic knowledge of Kafka or any messaging queue is very much required to gain confidence. So apart from knowing the different architectural pattern, one should have a fair understanding of different design pattern and design principles. Maybe we have already worked on different design patterns, like we know the creational patterns are there, structural patterns are there, and behavioral patterns are there, but one should have a fair understanding of these design patterns, how to apply and where to apply. These design patterns plays an important role because they help us in achieving some of the design goals, like abstraction, decoupling between the component, reusability, extensibility, and they help in terms of saving the time, improve the code quality, and promote the consistency in software cycle. And one should also be very comfortable in terms of applying some of the solid principles, KISS principle, and other areas as well. And basic hygiene, as we know, in terms of code, basic hygiene in terms of writing a clean code. Though we have couple of plugins which are available, like PMD is there, Findbug is there, and Code Style is there, which really help us in improving the coding process. But at least being an architect, he should also have a knowledge of design principles, design patterns, and also if you're coming from the data world or microservices world, and then different strategies like domain driven design or TDD, these techniques as well. So that's why one should have a fair knowledge of this design pattern and design principle, where to apply and when to apply. First of all, if you are striving for a data architect or a big data architect, then there are a lot of things that someone should try to explore, like distributed frameworks, batch processing, real-time processing, batch processing like Spark, real-time processing like Spark streaming or a Flink, and then you have NoSQL databases, and then you have distributed storage, you have orchestration, a lot of things are there. But even like very basic, even if you are not very specialized in this data specific roles, one should have at least basic idea of how the system works, basic understanding of data science, basic understanding of some of the NoSQL databases, and basic understanding of some of the core components of the data world as well. And then the next point is, so whenever we build a system, the important aspect is security. Security has multiple areas: security at rest, security in motion, and authentication. A lot of things are there. How you will store the credentials. So a lot of concept will come into picture, like encryption would be there, TLS would be there, credential management would be there, Open Connect, MFS, OAuth. A lot of things are there. JWT is there. At least one should have a fair knowledge of these tools, that how to apply and where to apply, because these, even if you're working, so whatever the use case that you're working, you need to apply security at any point of time. So it may happen that if you're working on a cloud, there are some cloud solutions also there, but at least you should know that you have to apply this solution for this use case. This is how I have to make sure that my data is secure during rest. This is how, when my data is in motion, I have to make sure that data is secure. Whenever I'm storing my password, how I can make sure that they are stored in a secure vault. So if there is an application where user authentication is required, if there is an application where service authentication is required, so all these things will come into picture when holistic view of the security is required. So overall, holistic view of the security is required. So we had discussed so many technical skills. So apart from these technical skills, there are also soft skills which are very much required in our day-to-day work. So being a software architect, he has to conduct a lot of POCs, technologies, he has to take architectural decision. He should be a good communicator because he has to interact with multiple stakeholders, teams. He should be a great team player because he has to collaborate between the different developers. He should be a great mentor so that he can lead the team, he can nurture the talent, he can mentor the people. He should be able to do some estimation in terms of high level, like how much effort would be required. He should be a good negotiator. He should be able to manage the stakeholder communication. So these are the very basic aspects of our day-to-day work of architect, where these things are very much required in terms of communication, leadership skills, negotiation skills, problem solving skills, because it may happen that someone has come up with a complex problem and then you have to solve that problem. So in this video, we started with some of the tips to start with, and then we came up with a detailed roadmap. We covered a lot of technology, we covered a lot of tools, we covered a lot of frameworks, and we covered different patterns also for becoming an architect. Now in future videos, I'll be covering lot many areas in terms of becoming an architect, be it like architecture pattern, design patterns, databases, data related things, API related things, security related things. So I'll be creating lot many videos in each of these directions, so that if someone is trying to become an architect, that journey could be expedited. Thank you so much for listening to me. Have a great day. See you in the next video.